Good afternoon, everyone. I hope you had a nice break, all refreshed, not too dozy at the end of the day, like I'm getting a bit dozy. But anyway, try to get this high energy. So I want to talk to you about how can you get more involved with OpenStack. And I'm John Garbutt. I'm currently an OpenStack technical committee member. I'm a principal engineer right now at StackHPC, which is a company based at looking at OpenStack and the HPC use case, as you might have guessed from the name. Stig did a great talk on what we're up to earlier. This is more about me talking about how to get more involved in OpenStack. So when I work out how to use a computer, cool. So I want to start with talking about my journey through OpenStack. I started on OpenStack in December 2010, working at Citrix. We were doing like a private cloud packaging of OpenStack, looking at how to make OpenStack work really well with Citrix Zen Server. Priorities change in big companies. Cloud.com was purchased. So I sort of moved more to looking at upstream OpenStack work and how to make, sort of concentrating upstream, making Citrix Zen Server work really well with OpenStack. That led me to sort of meet the great sort of upstream OpenStack community, going to the design summits, getting to meet lots of people. That was a really good experience, in part because I got to know the people at Rackspace Public Cloud, and I thought, you seem like good, crazy people that I could go work with. So I moved across to Rackspace Public Cloud. We were looking at scaling using OpenStack and Citrix Zen Server to build a public cloud, and that's what it's running on today. That was really interesting, fun times with all the scaling and everything else. Also fun times for me because I got a chance to get much more involved upstream doing code reviews. I became Nova Core. I started to get more involved in the design process and the design summits. I think I was the blueprint czar at some point. We have lots of strange names for things in OpenStack, it turns out. We just come up with names. Czar just meant person making sure a thing happens, really, in that context. So with some time getting involved in that kind of stuff, I was elected the Nova project technical lead for the Liberty and Mintaka cycles. It's a little while ago now. After that, I sort of stepped up and decided to do sort of the OpenStack technical committee work. So I've been on that. This is my sort of second election cycle because it's sort of yearly. You get elected for a year, and it's done every 6 months with sort of half the committee swapping over. So sort of my second cycle of that. It's been really good fun getting to know OpenStack and the upstream community. Most recently, I sort of started a couple of weeks back at StackHPC, sort of concentrating more on Ironic-based clouds, not just Nova-based clouds, so clouds where you're giving bare metal instances as well as virtual machines, not just focusing on the virtual machine side. So it's been a fun, interesting journey. So my IRC nick, my Twitter handle is John the Tuba Guy, and one of the questions I get asked is, so yeah, what's all that about? So I play the tuba. It's a bit of an obvious thing to say, but this is me with my quintet. Available in the Cambridgeshire area, if you're from Cambridgeshire, for your favorite weddings and everything else. So yeah, this is me with my quintet. Just thought I'd answer that question. So when it comes to sort of being involved in the upstream community, one of the questions I get asked and have been asked in the past is, how do I get this commit upstream? You know, I've been working on this. I've got this thing internally. It's fixed our problem, and I want to get this commit upstream so that I don't, when I next upgrade, I just get the fix for free. Seems a good question. I think it's probably actually the wrong question to ask. So I think we need to change the problem around ever so slightly. I think what you really want is, how do I fix my problem upstream? I think it's a much way better of thinking about it. So like, how do I get my bug fixed upstream? It's actually what you really want to do. Now, let me talk about why I think that's a good way of thinking about the problem. So I'm going to start by drawing a strange red square on the screen. Now, this is me trying to visualize a journey I've been through in my head about problems that I'm working on in OpenStack. So bear with me, it's a little bit abstract. I'll get to something concrete soon. So step one is, like me personally, coming in fresh to OpenStack, like what's my picture of the long-term vision for the upstream project. And it's this beautiful, rounded rectangle. So I think it's nice and neat. Bear with me, seems strange. So in this, I want to, like my solution that I've come up with fits beautifully in this long-term vision, fills a big hole, tick, looks great. So this is where I'm coming in as a contributor up to upstream. Now, I'm stepping out of that person's view and into the shoes of the upstream developer. Now, the upstream developer has this great vision of this beautiful circle as the long-term vision of OpenStack. They've probably not written this down very well, described it to anyone. This is what's in their head. The other thing they have in their head is the current view of OpenStack. So to like just deconstruct this picture a little bit, there's bits that they really want that have clearly been not finished yet, and there's some stuff that they're trying to get rid of. Stuff that we put in the first place and thought, ooh, we don't really want to do it that way. So that's where upstream is coming from. You know, they're trying to say, who can I find in the community to fill in these like white blanks? And actually, who can I find to work out how to get rid of these bits around the edge we don't want anymore and replace them with something that's going to fix people's problems without, breaking the whole idea. So that's kind of where these two camps are coming from in their head. So let's sort of go back and like compare these things. So when these two sides meet, they both start looking at your solution. Like when you start looking at the solution, it's really easy to start having arguments about, well, so you've got some good bits in your solution because we've got that little bit of the circle missing and you're filling that in, so that looks sweet. But what's all this bit that's outside of our vision is all a bit strange. And it's really easy to sort of get lost in the weeds in these discussions about like what's actually the thing that matters, which is where I sort of tried to come back to that, sort of worry about like let's talk about the problem. So there was a lot of talk, like Thierry did a good introduction of what's happening at the moment, and one of the things he mentioned was about the forum and the PTGs and the design summits. And like the insight to what's really happening there is it's lots of people sort of saying these are the sets of problems we need to solve, like which are the ones the most important, and like how do we fit these all together. So it's really important to see the whole sort of picture. And what you really want to happen in a perfect ideal world is you talk about the problem and you actually start understanding more of each other's problems, and you come to a picture where there's a joint solution that solves everybody's problems from the different people that are all coming together, and it starts to fit into the long-term vision very nicely. That's kind of where you want to get to. Hopefully that makes a little bit of sense in the sort of abstract and how you get all these bits together. So I wanted to take, there's a really interesting old tale that I think speaks to these kind of conversations really quite well without sort of picking out anything in particular. That and a picture of big elephants kind of cool. I don't know, it just seems nice. So there's this story of 3 blind people discovering that this thing called an elephant was in the village, and they were trying to argue about like what to try and describe it. And one person gets hold of the tusk and is sort of like it's this pointy thing, a bit like a dagger. Someone else is sort of like playing with the ear, and it's this flappy thing. And there's another kind of someone's playing with the tail, and it's like a paintbrush kind of thing. And they get to a bar and just start arguing about what how to describe this thing that they've just sort of felt. And obviously they've only seen sort of part of the whole picture. And I think it's an interesting allegory in lots of ways, but it always reminds me of design summit sessions, honestly. Because you get lots of people in the room with just a partial view of the problem, but the whole, where it gets really powerful is when you leave the room sort of discovering more about the problem that you're facing and more about how to implement it. As a software developer, I like to stretch analogies a bit too far, maybe, but let's keep going because it's fun. So on this elephant front, you could imagine arguing which bit to build first. And there's someone says, I've got this really good tusk, and it's, well, that's very interesting, but it's not going anywhere. And there's someone saying, well, I've got this plan to build this massive body, If you haven't got the legs, that's going to be really hard because it's hard to put the body back on the legs. I'm pulling this analogy far too far. Anyway, you get the idea. You get this discussion. So I think when it comes to this kind of thing, my sort of takeaway top advice is always focus on that problem that you're trying to solve and don't get too sort of attached or deep into getting this particular solution. Really, it's about, coming together and solving that problem. So I want to make it much more concrete. So to do that, I'm going to take a deep dive into some work that OSIC initiative did. So there was a collaboration between Intel and Rackspace, and we looked at live migration and looked at testing live migration, doing lots of VM moves, and trying to prove, does live migration work? How reliable is it? And we published a white paper. I'm going to publish these slides on my Twitter feed afterwards, and it'll have the link to the white paper in there. It's on Superuser, talking about the testing we did. Because if I did a talk on that, we'd be here all afternoon. So what I want to do here is just have a quick look at live migration and look at the things that came from that and what lessons we can learn on how we all sort of collaborate together. So I think it was kind of an interesting exercise. So first of all, this seems like a really dumb diagram to show at a conference like this, but I just want to make sure we're all using the same words before I start talking about live migration. So just to put stuff in blocks, a virtual machine generally has some CPU and memory. Generally, it has some networking, and generally it has some disks, which could be local or remote. We're all good so far? Excellent. The next piece is, let's take live migration, just split it into 3 simple steps, ignoring all the extra words there for now. The 3 simple steps are, the VM is running on the source host, the VM isn't running anywhere, and the VM is running on the destination host. I probably just broke the magic of live migration if someone hasn't looked at this, but the VM isn't running at some point, right? That's a crucial piece. Okay, so what do we do during live migration? And the reason for me going through this is just otherwise when I start talking about the bugs we found, it'll make absolutely no sense whatsoever. So the quick thing with live migration is the first thing you do is you try and make the execution environment on the destination as close as it is to the source. What I mean by that is, if you've got volumes attached on the source, you need to attach the volumes on the destination. Right? So any remote disks you get attached. Same with networking. You want the OVS rules to be correctly configured so that when you land on there, it's all good. So you've got OVS rules matching. For local disk, it's a little bit harder. The general approach that QEMU uses and many others is effectively you're mirroring the disk between the source and destination, the current writes. So the current writes are going to both source and destination. But then in the background, you sort of copy the rest of the disk so that way you've got all the disks there, we've got all the networking there. So that's the disks, the local and the remote and the networking. The remaining piece is the RAM and the CPU. Interesting whole talk in this, but the basic idea is you copy all of the memory from the source to the destination. In the meantime, this VM is still running, right? So you've got some more dirty memory, which is hopefully less than the whole of the memory you copied last time. So you copy a little bit more. And then you keep doing this until the point where you're happy to pause the VM because you're estimating that all the dirty memory that's left will be quick enough to copy across the network without worrying about the VM not being running. So when we get to that point, we copy the final bit of the memory, we copy all of the CPU state, then we start it on the destination, and we've got to the final stage. So VM goes from source not running, destination. That's the basic sort of summary. Okay, so let's have a reflection on some of the things we found and how they were interesting. So the first bug that we ran into was, well, I should quickly go over the testing we did. Effectively, the testing even though it was in a sort of 20-node cloud, was really moving lots of VMs from source host A to source host B and then back again in a loop. Actually quite simple. There was a set of tests done for like small VMs, medium VMs, large VMs. The white paper covers the details of what those are. Large wasn't particularly large, but large enough to be interesting. The only other variation on that small, medium, large was some of them had local disk, some of them had remote disk. So some of them were doing the block migrate versus non-block migrate. And the basic idea was let's get some benchmarking results. Let's show it's all working, 100% success rate, rubber stamp, yay. And I was talking with the operator doing the testing, that yeah, it's all good apart from these little ones that went wrong. So it was kind of like, well, we should dig into this. This could be interesting, right? Did you run it twice? It's, oh yeah, I ran it the second time, the same thing happened. And so as a developer, like light bulb came on. It's like, sweet. So if we roll back from that conversation to other conversations at the summit, anecdotally, we had a lot of operators saying, live migrate usually works, but sometimes not so much. And we've been trying really hard to get some of the data from that. And so someone to walk up who's like got this test that's reliably reproducing the bugs, like, so yay, happy times. So that was a good thing. So yeah, it's probably the first time that someone doing benchmarking with errors, my eyes sort of just lit up. It's like, fantastic, we have a mine of information. So what did we find? The first thing was about live migrates getting stuck. So here's the symptom. You do the live migration and it just sort of seems to take forever. Now, this is one of the things we heard operators saying about. With doing some log analysis, what actually happened was the second bug, which caused the first one. So the first two is really kind of one monster bug. So what happened was during cleanup, there was a little bit of a race talking to libvirt to basically undefine the domain. It actually errored out with can't undefine domain, domain is already undefined. Yay. So I've already done my work, go away, was the error. I mean, for the developers in here, turns out that was a cut and paste bit of code from somewhere else, and the error handling only got fixed in the place it was cut and paste from. So, discovery. Anyway, backing out of all that context, what we found, we could actually reliably reproduce this bug. So first of all, we could make sure that when this bug happened, the state management system didn't miss the fact that it finished. So it went to the error state. Obviously, going to the error state wouldn't be the fix, so it's also like fix the root cause so that it doesn't go into the error state anyway. And the key thing is we could actually, put these fixes upstream, pull them onto our code patch, deploy them to the benchmarking system, and actually see those errors drop away. The other error we found was actually kind of interesting, was a timeout error. So the live migrations in Nova shouldn't ever go on forever. The idea is that there's a timeout, at which point Nova says, no, this thing will never complete. We assume it will never complete, so we'll just kill it. And it goes to basically just reverts back to where it was rather than the error state. But you finish the live migration. So there were a few cases where we found that it looked like the VM sort of got stuck on a host, effectively, because you tried to live migrate and it timed out. When we dug into this, the timeout that triggered was a timeout monitoring the memory copy. So I spoke about all the memory copying. What it was actually doing was it was saying, have you made any progress? No. Have you made any progress? No. What was actually happening is we were copying the storage. So we were still copying the storage from the source to the destination, and it was monitoring the memory, which happens next. So it wasn't making progress. Whoops. So that's actually been disabled. Like right now, the current fix is to disable that timeout. It doesn't work in most cases. So we're actually working with the upstream QEMU community to work out how we get better monitoring of that particular progress, when it's progressing during that stage. So it's a bit of heuristics that just went horribly, horribly wrong. So lots of different classes of bugs there, lots of interesting things. And I wanted to try and extract from that interesting exercise which was really just me geeking out about Live Migrate, because that's fun. Like, what can we learn from this, and how can we try and reproduce this success? Like, it's an interesting way of sort of going about it. So the sort of like observations I want to make about this. First of all, like the key thing, we have a problem with, like, there's many ways in which you can create an OpenStack cloud. Reproducing that error can be a pain. The other piece is you need to kind of align that ability to reproduce the error with the ability to actually, this sounds obvious, but debug the problem. So the ability to actually work out which logs there were. From memory, in this case, actually, the error logs were enough for me to work out what was happening. The problem I hit was the error logs I got given were the error logs from the Tempest run in the first place, which wasn't very useful. So I just got the waiting for active state never happened, I think was the error log I got originally. So the error log you need in this case was actually on the Nova Compute node logging. If you aggregate your logs, it's much easier, but in the test environment, it wasn't aggregated. So working with the upstream community with your problem to actually work out, like, do I have the correct logs? And that kind of communication is really quite important. Otherwise, it's just really hard to work out what is going on. There's been some talk, but the direction hasn't gone there. One thing that I think as a community we could look at working on is building sort of like bug tool systems to actually help with that, getting the correct log for the correct error API, API error, and that kind of wiring up piece. But it's a piece of work if someone fancies it. The next piece, which is harder, is the ability to actually help test the fix. It was really good to get that feedback cycle going, just to be able to say, yes, this does confirm it works. So the next piece I wanted to step into was really like, what's the common theme between all these pieces when you're working upstream? And for me, I think the common theme is kind of summed up quite well by To Kill a Mockingbird. And I'm not saying that just because it's got taken off the GCSE syllabus. For people in the UK that went through learning To Kill a Mockingbird and now people aren't. I think empathy is the one-word summary of this. I think it's just important that all sides like work really hard to understand where the other person is coming from. I think that's the key thing, to just take a step back. That's the kind of secret sauce, if you will, between all of these things. Okay, so I wanted to sort of go on to like, what can I actually do? You've been talking to me quite a while. What can I do next? I think the first piece of encouragement follows on from what Thierry was saying in the keynote. Like, there are lots of different kinds of contributors from lots of different walks of life. There's contributors that are, come in with the one fix, and that is super important because that's the one fix we wouldn't have. We just wouldn't see that problem, and that's going to, that one patch may solve issues for all sorts of people. So just come in, join in, have a go is my recommendation. Come talk to people. We're not totally too scary, and we try not to be. So next steps. I've written lots of things here. The first thing is come say hello. So you've actually done the first step. So congratulations, you're here. So hello. Good work. And honestly, like, if you're like, you've got this problem or you've got this idea, just come talk to people. It doesn't have to be a fully baked thing. It doesn't have to, it just has, if it's just a little light bulb, hey, this is a thing. I think it's a good way of just coming and getting involved. Obviously, one of the production issues and that aside, like the bugs are a great way in, I guess is one way of saying. If you've got that little fix that works for you, it's a great thing to come and talk about. But within the context of let's fix the problem together. It may be that fix breaks like half another set of users, so you have to work through that and come up with something. at the end, but getting that starting point, actually talking about it, is really, really useful. There's lots of things I found myself doing in the last few weeks as I started to come to projects anew. So I've been working with Nova for an awful long time, but in my new role, I'm getting to see lots of other projects. Just things like I was using, what was the example? I don't want to name and shame people. Maybe it's Sahara or something. I was using someone's README, and I was just like clicking on the link, and it's like, oh, the link's broken. So, push the patch up for the link fix. Like on the README page on the GitHub repository, it's just like little things that just help the next person. I think it's just good for us all to watch out for those. And they're really good ways of just sort of getting to know people and just getting, smoothing the wheels of like, oh, what's that Garbutt thing that I have to push the patch to? Like if you're doing that with a little simple typo fix, it just takes all the pain out of all the other bits of getting started. It's just really a good way of getting going. And I guess the last next step is sort of towards the end of the presentation is like, feel free to ask me questions or, get in touch. But yeah. So are there any questions at all? Or was it far too scary in a big room? I don't think I'd ask questions, so that's fair enough. But thank you very much for listening. It's been a pleasure.